Welcome back to Young Tutor. Today we'll be taking up the topic rational numbers. We'll be just continuing with where we stopped last time. As I said, we'll be only doing multiplication and division. Multiplication of rational numbers is very simple. It's exactly the same as how we multiply integers, and also it's just a combination of the multiplication of integers and the combination of multiplication of fractions. So all we are doing is taking a fraction. For example, let's take the number minus 5 by 14 and we'll multiply it with minus 1 by 5. So we can see in this case that 5 and 5 are divisible because we can divide both of these numbers, that's minus 5 and 5. In this case, as this now 5 does not contain a minus, the minus will not be taken away, only the 5 will be. So over here we can see that as there is a minus, this is equal to minus 1. And we've also learned earlier in during the multiplication of how we multiply two integers. We've learned that minus times minus gives a plus. So this will be plus 1 by 14. So you can see how simple it is to multiply. This is just an example. Where this next example we'll be taking will be 3 into 2 by 3. 3 into 2 by 3 is a simple setup. It's also positive. It's a positive. Now both are positive, so we don't need to worry about negative sign in this case, as two positives cannot turn into a negative. We can write 3 as 3 by 1, making this 3 into 2 by 3. If you can see, because 3 into 1 is 3, so we can just do it like this. We know that 3 and 3 can cancel each other out, giving us the answer of 2. This is all. This, if you can check without cancellation, we can make this 3 into 2 6, and 6 by 3 is also 2. So this is just a simpler way and quicker way to do it. A third and last example that I will be taking for multiplication of rational numbers will be multiplication with 0 and how we actually multiply with 0. I'll be taking two variables for this, a and b, a by b times 0. So we know that any number multiplied by 0 equal to 0 itself. We've learned this for a long time now. But 0 by b, is it actually equal to 0? Because a into 0 is 0 and as b stays 0 by b. 0 by b, is it equal to 0? Yes, any number. Let's take for example 0 by 100, it's still equal to 0. So 0 by b is also equal to 0, as any number which has a numerator of 0 includes 0, it's will equal to 0. Now let's start up with division. Division is just like multiplication, but you have to just add on a little bit more to it. So let's take for example 3 by 4 divided by 2 by 5. These two numbers are very simple to divide because all we are doing is taking the reciprocal of this number. If you remember last time I taught you about how reciprocal works. Reciprocal is nothing but flipping the making the numerator denominator and denominator numerator. So, and we have to switch the division sign to a multiplication sign. All this will everything. So 3 by 4 will stay 3 by 4. We'll put a multiplication sign as I said earlier, and we'll be making it like this. Now you can see that what we had earlier just became into a multiplication problem. Now we remember how to do multiplication as we just learnt it a few seconds ago. All we'll do now is continue with the normal multiplication. We cannot cancel anything in this situation. So all we'll do is multiply the numbers. 15 by 8 is the answer. If you can see, it's an easy answer and it's a very easy way to divide two numbers. Let's take another sum which has a negative sign in it. Let's take minus 3 by 5 divided by 4 by 11. over here also it's a very simple problem. All we have to do, as earlier if you remember we did, we had to change the multiplication sign, take the first number as it is, and take the reciprocal of the second number. So we are all we are doing is take the first number as it is, put the multiplication sign, and write 11 by 4 because we are taking the reciprocal. Multiplication with these two numbers is easy, but as we have a minus sign will stay the same because 11 does not have a minus sign. 3 into 11 is equal to 33 by 5 into 4 is equal to 20. But we cannot continue the further division, so this number stays as it is, as an improper fraction, but as we'd said, a rational number. A third and last one we'll be taking for this will be minus 7 by 8 divided by minus 3 by 6. Minus 3 by 6. So minus 7 by 8 will stay the same into minus 6 by 3, because the minus sign, to make it a normal fraction, you have to take the minus sign up. So it will stay minus 6. So the minus sign which was on 3 will go to 6. The value does not change. Equal to, so minus into minus equal to plus. Therefore, 7 into 6 will stay 42 and not minus 42 by, so it will be 42 by 3 into 8, which will be 24. But we can see over here that 8 and 6 could have been cancelled earlier. Also, if you see that another way to do this, I have done it here, but we can simplify this equation to get it to its simplest form. To make this number down till the simplest form, first we can divide this by 2. 8 and 6 can divide by 2 to give 3 over here, and 8 will become 4. Here also we can see that we can cancel the 3's out, which means all there is left here is minus 1. Which means we can get 7 by 4. Because minus into minus equal to plus, and 4 stays as it is, and 7 stays as it is. So it's just 7 by 4. Another and last topic that we'll be covering will be about how can rational numbers be written as fractions, as decimals. So we can, let's take the example of 1 by 4. 1 by 4, if we remember, all we can do is write this thing as 0.25. It's just a simple division because we're dividing 4 by 1, which gives 0.25. Also, it's very easy to remember as it's nothing but a quarter of a number. Easy to remember as a quarter of a dollar is 25 cents. So easier way to remember is like this. So this is how we can write. This is called terminating decimals. That is, they have a point where they stop. After the division takes place, there is an actual place where you get a remainder 0. Now, another example that I'll be showing you is non-terminating decimals. This is the only way we can write a number as a terminating decimal, but there are two ways to write non-terminating decimals. That is non-terminating recurring decimals and non-terminating non-recurring. Non-terminating recurring decimals example could be minus 1 by 3. Minus 1 by 3 is a non-terminating decimal, as if when we divide this we get 0.3333 so on. 0.333 so on. We can also write this as 0.3 bar. All bar says is that it goes on forever, that one set just keeps on repeating. Now let's take an example for non-terminating non-recurring. These numbers are also called irrationals, that is, they are not considered to be rational numbers. The most simplest one that we know is pi. Pi is a non-terminating non-recurring, as it's nothing but 3.14. These are the most always used digits which we use for estimating pi. and it just goes on forever like this with some random combinations of numbers that never repeat on their own. This is called non-terminating, non-recurring decimals. These cannot be written as fractions. Today's homework for everyone will be, we'll start up with multiplication. For multiplication, we will take the numbers 3 by 4 into 5 by 6. It's very easy, you can go ahead and do it on your own. Try it at home by yourself. You can also do some cancellation. That will be a hint for this one. The second one that we'll be taking will be for division. 2 by 9 divided by 4 by 7. Again, a very simple one. There are no complexities in these. That is, it's not very complex. It's very simple to solve. Comment the answers down below, and as always, subscribe to the channel and like and share this video if you want to. If you like the videos. Also, if you have any doubts regarding anything related to the topics, you can comment it down below in the comment box. Thank you for watching.